Here is a question that sounds simple until you try to answer it. Where does the universe end? Go ahead, picture it. You are traveling outward faster than anything has ever moved, past the last galaxy, past the last faint smudge of light. And then what? A wall, a curtain, a sign that says nothing beyond this point? Or does it just keep going forever in every direction with no edge at all? Sit with that for a moment, because both answers feel impossible. A wall is impossible, because what would be on the other side of it? And forever is impossible too, because your mind simply refuses to hold the idea of a thing with no end. Try it right now. Imagine the wall. Now imagine standing on it, reaching a hand past it. Where does your hand go? You cannot stop the picture. And now try forever. Imagine flying and never once slowing down. Your mind gets tired long before the universe does. Neither picture will hold still. You have run into one of the oldest problems there is. People have chewed on it around fires and in temples and in lecture halls for thousands of years. Great minds have gone gray over it. And I want to tell you something that might surprise you. We have found an edge. There really is one. It is measured. It has a distance. You could write it on a napkin over breakfast. But here is the twist that makes this whole thing worth your next half hour. The edge we found is not the edge of the universe. It is the edge of what we can see. And those two things are so different that once you understand the gap between them, you will never look at the night sky the same way again. I mean that literally. The next clear night, you will stand under those stars and feel the whole thing differently. Most people, when they hear scientists found the edge of the universe, imagine the edge of everything, the end of the stuff, the final shore, the last brick in the wall of creation. That is not what was found, not even close. And the difference between what people believe and what is actually true here is enormous. It is not a small correction. It changes everything about what that headline means. So let us go find that edge together, slowly, carefully, one step at a time, with no jumps you cannot check. And I promise you will do the finding yourself. I am not going to hand you an answer. I am going to hand you a path and let you walk it. Before we can talk about the edge of anything, we have to talk about how you can possibly know something is out there when you cannot go and touch it. This is the part that matters more than any answer. Because if you do not trust the tool, you should not trust anything it tells you. And this is where most explanations cheat. They tell you the answer and skip the part where you get to check it yourself. I am not going to do that. We are going to earn every step. Here is the only tool we really have for the distant universe. Light. That is it. That is the whole toolkit. Everything you will ever know about a galaxy 10 billion light years away. You know, because a little bit of light left that galaxy, crossed an unimaginable gulf, and landed in a detector. Nothing else makes the trip. No sound, because sound needs air to carry it, and space has none. No smell. No messenger you could send and get back in a human lifetime, or in 10,000 human lifetimes. Just light, a faint trickle of photons, and from that trickle we reconstruct entire worlds. Now sit with what that means, because it is stranger than it first sounds. Light is fast, but it is not instant. It has a speed, and that speed, the speed of light, is the fastest anything can travel. Not just the fastest we have built, not the fastest we might build next century, the fastest anything can go ever, as far as we can tell, anywhere in existence. That is a limit baked into space-time itself, the single fabric of space and time woven together into one thing. You cannot bribe it. You cannot engineer around it. It is a wall in the rule book, not a wall in the sky. And that distinction is going to matter enormously before we are done. So light takes time to arrive. And that changes the whole game. It changes it more completely than almost anything you have ever been told. When you look at the sun, you are not seeing the sun as it is now. You are seeing it as it was about 8 minutes ago, because that is how long its light took to reach you. Do the arithmetic yourself, right here, so you own it. The sun sits about 93 million miles away, and light crosses roughly 186,000 miles every single second. Divide the one by the other, 93 million divided by 186,000 lands. You at around 500 seconds, a little over 8 minutes. So if the sun vanished this instant, snuffed out clean, you would enjoy 8 more minutes of ordinary sunshine, blissfully unaware, birds still singing, and only then would the sky go dark. The news of its death would still be crossing the gap. Now stretch that idea, because it only gets better. The nearest star beyond the sun is a little over 4 light years away. And here I need you to catch a word that trips almost everyone. A light year is simply the distance light travels in a year. It is a distance, not a time, even though it sounds exactly like a time. Say it slowly to yourself. It is how far, not how long. A light year is a ruler, not a clock. So that nearest star you see as it was 4 years ago, the light hitting your eye tonight left before some of the things that happened in your own life this week, and a galaxy 2 million light years away, you see as it was 2 million years ago, back when your distant ancestors were figuring out how to hold a rock with intent and crack open a nut. Do you see what this does? Looking out into space is looking back in time. There is no way around it. It is not a poetic flourish. It is plain plumbing. The further away a thing is, the older the image you get, with no exceptions and no escape. You are never, ever seeing the universe as it is. You are seeing a stack of postcards, each one older than the last, all arriving at once, all landing in the same instant, on the same night sky. The bright star and the faint galaxy sit side by side, apparently neighbors. But one image is a few years old and the other is millions of years old. The sky is not a photograph. It is a collage of 1,000 different times, pasted together by the accident of when each beam happens to arrive. And this is the key that unlocks the edge. Follow me carefully now, because from here it is just a short walk of clean logic, and every stone is one you can test with your own foot. The universe has an age. That is not a guess pulled from the air. That is not a number someone in a robe simply declared. There are several independent ways to measure it. Roads that start in completely different places and arrive at the same door. One method reads the expansion rate of the universe and runs the clock backward, the way you might rewind a film of an explosion to find when it began. Another reads the temperature and the ripples in the glow of the oldest light and works out how long that light has been cooling. Another counts the oldest stars we can find in the oldest clusters, works out how long stars of that type take to age, and finds none older than the number the other methods predict, which is exactly what you would want. If we found a star older than the universe, we would know something was badly broken. When separate methods that could easily have disagreed instead agree, you start to trust the number. That is the whole logic of it. 3 roads, 3 toolkits, no reason they should match, and yet they land in the same neighborhood. A little under 14 billion years, roughly 13.8 billion. Hold that number gently in your hand, because everything now hangs off it. If the universe is 13.8 billion years old, then light has only had 13.8 billion years to travel, not a second more. Light from anything further away than that has simply not arrived yet. It is still on its way. It has not had time to reach you, not because it is faint, not because it is hiding behind something, not because your telescope is too small, because the clock has not run long enough for the messenger to cross the distance. So think about what that creates. A boundary, not a wall made of anything at all, a boundary made purely of time. There is a distance beyond which the light has not had long enough to cross the gap and reach your eye. Beyond that distance, you see nothing. Not because nothing is there, because the messenger is still in transit, still crossing the dark, and will keep crossing it long after you and I are gone, long after the earth itself is gone. That boundary has a name, the edge of the observable universe. Some call the whole idea a horizon, and that word is chosen with care. Think of the horizon at sea. It is not the edge of the ocean. The ocean keeps going. It is just the line beyond which the curve of the world hides the rest from you. This cosmic horizon works the same way. It is a line beyond which information has not had time to reach you, and that is exactly what an event horizon is in the deepest sense, a boundary past which no signal can arrive. This is the edge that was measured. This is the edge in the headline you saw. Now, you might expect that edge to sit 13.8 billion light years away. 1 light year of distance for every year the universe has existed. Reasonable guess, honest guess, the guess I would have made too. Wrong though, and the reason it is wrong is one of the most beautiful things in all of this, so let us not rush it. Space itself has been stretching this whole time. The universe is expanding, and here I have to correct a picture that almost everyone carries by default. It is not exploding into some empty room that was already sitting there waiting. There is no room outside. It is the room itself that is growing, every part of it stretching away from every other part, like the surface of a balloon being blown up, where every dot on the rubber drifts away from every other dot with no dot at the center. So the light that has been traveling toward you for 13 billion years set out from a place that has, in the meantime, been carried much further away by the stretching of space underneath it. Picture a photon, a single particle of light, crawling patiently across a rubber sheet, while someone keeps pulling the sheet wider and wider in every direction. The photon makes progress, yes, but the spot it left behind keeps drifting further off. When the photon finally arrives at your eye, the place it came from is now far beyond where it was when the journey started. When you do the arithmetic, that properly accounts for all that stretching. The edge of the observable universe sits not at 13 billion light years, but at around 46 billion light years in every direction. More than 3 times the naive number, and every extra mile of it earned by the expansion of space. Let that number breathe. 46 billion light years. That way, and every way you point. A vast sphere with you inside it. And you, wherever you happen to be sitting reading this, are at the exact center of it. Dead center. The middle of a sphere 92 billion light years across, which sounds like it makes you very special indeed. It does not. And understanding why is the last and most important piece of this whole foundation, so stay with me. Everyone is at the center of their own observable sphere. Everyone, a creature on a planet 10 billion light years from here, if such a creature exists, also sees an edge 46 billion light years out in every direction, with itself sitting neatly at the middle. Its sphere and your sphere overlap in places, like 2 soap bubbles pressed together, but they are not the same sphere. It can see things you can never see out past your horizon in its direction. And you can see things that are forever hidden from it out past its horizon in yours. There is no true center of the whole thing. There is just the plain fact that light reaches each observer from a limited distance around them, and each observer therefore sits quite naturally and quite unavoidably in the middle of their own reach. This is the Copernican principle at work. The idea that you are not in a special place, that your spot is ordinary, that the view from here is much like the view from anywhere else you could stand. And it is worth remembering how brutally reliable this principle has been. It has never once let us down. We thought the earth was the center of everything, with the heavens turning around us. It was not. We shifted the throne to the sun and thought that was the center. It was not even close. We thought our galaxy, the Milky Way, was the whole show, the entirety of creation. It turned out to be one galaxy among hundreds of billions. Every single time we assumed we were special, we were wrong, and often embarrassingly wrong. So the honest position, the position with the best track record by far, is this. The edge of the observable universe is not a property of the universe out there. It is a property of you, the observer. It is simply how far your particular postcards have had time to arrive. That is the foundation, and it is solid rock. Light is the only messenger. Light takes time. The universe has a finite age. Therefore, what you can see is finite, even if what actually exists is not. Read those 4 sentences back to yourself, slowly. Every single one of them is something you can check with your own reasoning, and not one of them asks you to trust a robe or a title or an institution. Everything from here builds on that foundation. So let us build, and let us build tall There is a wall out there, and it is the oldest thing you will ever lay eyes on. Older than every star, older than every atom in your body arranged the way it is now. I told you the edge of the observable universe is made of time, not stuff. Let me show you the deepest layer of that, because it is genuinely one of the strangest facts I know, and once you see it clearly, you cannot unsee it. It will follow you around. Point a good telescope at the darkest, emptiest patch of sky you can find, a spot with no stars, no galaxies, nothing at all to the ordinary eye, just black. Stare long enough, gather enough light, listen patiently in the right wavelengths, and something appears, a faint, even glow coming from every direction at once, not from any object you could point at, from everywhere, evenly, filling the whole sky like a fog that has no source. Turn the telescope to the left, it is there. Turn it to the right, it is there, at almost exactly the same brightness, matched to a remarkable precision, a steady hum of light soaking the entire sky in every direction you can aim. Here is what that glow is, and follow the reasoning, because it is airtight and you can build the whole thing yourself from parts you already have. The early universe was not the cold, dark, roomy place we live in now. Run the expansion backwards in your mind, like rewinding that film. Everything gets closer together. Closer means denser, more crowded, more packed. And denser means hotter. In the same plain way that the air in a bicycle pump gets warm under your hand when you squeeze it, because you are cramming the same energy into less space. Go back far enough, squeeze hard enough, and the whole thing becomes a searingly hot, uniform fog. And I want to be precise about this, because it is easy to picture wrong. It was not stars sitting in a fog. The universe itself was the fog. Everywhere, every point, hot enough to glow like the inside of a furnace, hotter than that, so hot that atoms could not even hold themselves together. The electrons were torn loose, and everything was a churning soup of bare particles. In a fog that hot, light cannot travel freely. This is the crucial step, so let us go slowly. Light bounces around, trapped, scattering off all those loose charged particles, knocked sideways again and again, the way light cannot get cleanly through a thick cloud, or through a glass of milk, or through fog on a road at night. The whole universe was opaque. There was nothing to see, in principle, because seeing requires light that travels in a straight line from a thing to your eye. And no light could do that in the soup. Every beam got knocked off course before it went anywhere at all. If you had somehow been there, you would have seen a glowing blank in every direction and nothing beyond your own nose. Then the universe expands and cools. It keeps stretching, and stretching thins the soup and drops the temperature. And at one particular moment, about 380,000 years after the beginning, it cools just enough for a threshold to be crossed. The loose particles finally calm down. The electrons pair up with the bare nuclei and settle into the first stable atom. And the moment they do, the fog clears. The soup turns to clear glass. Suddenly, light can fly free in straight lines. For the first time in the history of everything, the lights quite literally came on. And that freed light has been flying ever since, uninterrupted, for nearly 14 billion years, most of it never hitting a thing. Some of that very same freed light is still arriving right now, today, this second, from every direction around you. But it has been stretched. Remember the expanding rubber sheet. All those billions of years of expansion have stretched the light itself, dragged its waves out longer and longer, cooled it from a blinding furnace glow down to a faint whisper of microwaves, the very same family of light your kitchen appliance uses to warm a cup of coffee, but unimaginably ghostly faint. We call this glow the cosmic microwave background. And it is the wall, it is the redshifted echo of the moment the lights came on. Redshift being exactly that, stretching of light toward longer, cooler, redder wavelengths as space expands underneath it while the light is in flight. It is the furthest thing you can ever see. Not because it is the edge of the universe, but because you physically cannot see one step past it, beyond it, further back in time, is the fog, and the fog is opaque. Light cannot cross it. So no matter how good your telescope, no matter how large the mirror, no matter how long you stare, or how clever your instrument, you reach that glowing wall and you stop dead. It is a horizon made of the exact moment the universe became transparent. A curtain drawn across the stage. And behind the curtain is not the end of the theater. It is simply a room too foggy to photograph. Now here comes the turn, and it is a good one. You might think, well, fine, it is a wall for now, but surely we could invent a better telescope one day and eventually punch through it. Bigger mirror, sharper detector, more patience. No. And this is precisely what makes it so profound, so worth sitting with. It is not a limit of our technology. It is a limit written into the physics of the thing. Light simply does not exist from before that moment, at least not light that can reach you. Because before that moment, no light could travel in a straight line at all. So no straight line image was ever created to be captured. The information is not merely faint, waiting for a better instrument. It is genuinely, permanently absent. You cannot sharpen your way to a photograph that was never taken by anyone. There is a hard ceiling on what can ever be known through light, and we are already pressed right up against it, nose to the glass, fingertips on the ceiling. Sit with that, really sit with it. The cosmic microwave background is not just old, it is the oldest light there can be. There is no older photograph anywhere for anyone because before it, there were no free photographs to take. We are staring at the baby picture of everything, and there is no picture from before, ever, for anyone on any world, no matter how ancient or clever their civilization. Every observer in the entire cosmos, wherever they sit, hits the exact same wall. It is the universal floor of what can be seen. A single shared limit stamped onto every eye that will ever open. But there is something almost nobody notices here, and it is the part that thrills me most. So lean in. That wall is not the edge of what exists. It is only the edge of what has reached us. The fog was everywhere. It was here, right where you are sitting reading this, as much as it was out there at the far horizon. The atoms of your body, the iron in your blood, the calcium in your bones, all of it traces back to that same hot fog. You are made of the same stuff as the wall. And the matter that made the part of the wall we now detect, the stuff whose light took 13 billion years to reach us, that matter did not stay put and pose politely for the photograph and then stop existing. It kept expanding. It kept cooling. It kept clumping together under gravity. It formed stars. It formed galaxies. It is out there right now, at this very moment, aged and mature, full of light, full of planets, probably full of worlds with weather and oceans and who knows what else, doing everything our own patch of universe has done over the same billions of years. We just cannot see it as it is now. We can only ever see the wall it left behind. We see the fog it used to be, because that is the light that happens to be landing on our detectors on this particular night. The light showing its grown-up self, the galaxies it has become, will not arrive for billions of years yet, if it ever arrives at all. And thanks to the relentless expansion, stretching the road longer even as the light travels it, some of that light will never reach us. Not in a trillion years. The road grows faster than the messenger can walk it. So the edge is real, and it is measured, and it is genuinely the most distant thing observable. And it is still absolutely and completely not the edge of the universe. It is a snapshot of a single moment, not the end of a place. What lies beyond it in space is more universe. Ordinary universe, doing exactly what our own patch is doing right now. We are simply too late or too early to catch its light in its grown-up form. We arrived at the cinema in time to see only the opening frame of The Neighbors Next Door. That is the wall, made of the oldest light there is, hiding a present we will never, ever witness. Now, let me take you somewhere completely different, and I promise you it connects back to everything we have said. The universe beyond our wall is not empty. It is stuffed with galaxies, uncountable numbers of them. And the ones nearest that edge are trying to tell us something we did not expect at all. Here is a thing you can reason your way into from your armchair with nothing but what we have already built. If looking far away means looking back in time, and we have proven to ourselves that it does, then the most distant galaxies we can see are also the youngest galaxies that ever existed. We are catching them as newborns, as infants, just after the fog cleared in the first few 100 million years of everything. Not old galaxies that happen to sit far away, young galaxies frozen forever in an old image delivered to us across all that time. That distinction matters enormously, so hold it. And for a long stretch, we could barely see them at all. Their light is faint, being so far away. But worse than faint, it is stretched. Remember the expansion. As space stretches while the light crosses it, the light itself gets stretched too, dragged toward the red end of the spectrum and then right past it, out of visible colors entirely, and into the infrared, into wavelengths your eye simply cannot register. This is redshift again, the same effect that cooled the wall. And the more distant the source, the more violently redshifted its light. The earliest galaxies are redshifted so hard that their glow has slid completely out of visible colors and into the infrared. The warmth light your skin feels standing near a fire, but your eyes can never see. An ordinary telescope tuned to visible light is simply blind to them, stone blind. It is like trying to hear a whistle pitched far too high for your ears. The sound is genuinely there in the air. Your instrument is just wrong for it. So we built a telescope tuned to exactly that stretched light. An enormous mirror, far larger than anything sent up before it, folded like origami to fit inside a rocket and unfolded once it was out in the dark. Parked 1,000,000 miles from Earth, 4 times further than the moon, kept bitterly cold behind a great shield the size of a tennis court, so its own heat would not drown out the faint infrared whisper of the early cosmos it was straining to hear. Because a warm telescope glowing gently in infrared, trying to detect faint infrared from the edge of time, is like listening for a single pin dropping inside a running engine. So they made it cold, colder than almost anything in the solar system, and they made it huge, and they aimed it straight at the edge and told it to stare. Here is what our careful reasoning told us to expect out there. In the beginning, galaxies should be small, runty, just barely starting to assemble themselves. Gravity needs time to do its slow work, to gather the gas, to form the first stars, to pull loose structures into organized shapes. And gravity works at a pace set by orbital mechanics, the same patient clockwork that governs how any two things swing around each other, from moons to whole galaxies. So the first galaxies should be little faint smudges, disorganized, a few stars huddling together in the dark, only slowly building themselves up over hundreds of millions and billions of years. That was the prediction, and it was a good one, built on the solid, well-tested physics of how gravity clumps matter together over time. It was not a lazy guess. It was the careful, sensible, reasoned expectation of people who knew exactly what they were doing. Then we actually looked. We pointed the cold giant at the edge and gathered its light. And the early universe was not full of runts. It was full of galaxies that looked too big, too bright, too grown up, too organized for how little time had passed since the fog cleared. Galaxies that, by our own careful reasoning, should have needed billions of years to assemble, sitting there apparently fully formed just a few 100 million years into the whole story. It was as if you photographed a hospital maternity ward and found the newborns already standing up in their cots, already walking, already talking in full sentences, already tidying the room and asking about dinner. The image simply would not fit the story you had brought along to explain it. Something was off, and it was off in a way you could measure. Now, here is where scientific literacy matters more than anywhere else, and where the terrible temptation to shout revolution has to be firmly resisted. Scientific literacy is not knowing a great pile of facts to recite at parties. It is knowing exactly what to do when a fact and an expectation collide head-on. When an observation clashes with what you predicted, there are always several possibilities on the table, and honesty means holding all of them up to the light at once, weighing each one fairly instead of grabbing the loudest and most exciting one and running for the door. So let us hold them up, one at a time, the way an honest thinker must. Maybe our distances are slightly off, and these galaxies are a touch closer, and therefore a touch younger and easier to explain than we first thought, Since the entire measurement hangs on reading their redshift exactly right, and reading it from a faint infrared smudge is genuinely delicate work. Maybe some of them are not truly as massive as they first appeared, because a galaxy packed with a few unusually bright young stars can masquerade in a distant smudge of light as a galaxy packed with a great many ordinary ones, and telling those two apart at that distance is hard. Maybe the early universe simply made stars faster and more furiously in its first act than our models ever allowed for, and the models need careful mending rather than throwing out entirely. Or maybe, just maybe, something deeper in the whole picture needs adjusting. Something about how the very first matter gathered itself together in the opening scenes, something about the dark matter whose gravity may have set the scaffolding. Do you feel the shape of this? It is the same shape as the wall. An observation, honestly reported, that pushes back hard against what we assumed we knew. This is what a healthy science actually looks like from the inside. Not a set of tidy answers handed down from on high and memorized, but a set of expectations that reality is completely free to violate at any moment without warning, and a room full of careful people arguing in good faith about which repair the evidence actually demands. Nobody in that room owns the truth. They are all just trying to be a little less wrong than yesterday. And here is the turn. The fact that reality violated our expectation is not a failure. Read that twice. It is not a failure. It is the single most valuable thing that can possibly happen. Because a prediction that could have been wrong and then turned out wrong has just taught us something genuinely new about the world. That is precisely what makes an idea worth having in the first place. It has to be falsifiable, meaning there has to be some possible observation, some result you could get that would prove it false. If nothing could ever contradict a claim, if it comfortably survives no matter what you see through the telescope, then the claim actually tells you nothing at all. It is just noise wearing the costume of knowledge. It feels like understanding and delivers none. Our tidy story of slow galaxy assembly was falsifiable. It stuck its neck right out over the block. It said plainly and bravely, "You will see runts out there. We looked, and something did not fit." So the story gets richer now, and we are closer to how things actually are, precisely because the universe refused point blank to agree with us. A theory that risks nothing gains nothing. A theory that dares to be wrong and survives is stronger for it. And a theory that dares to be wrong and fails has done its job by clearing the ground for a better one. So the edge of the observable universe is not just a wall of old light. Just short of it, there are galaxies quietly breaking our best assumptions, and every one of them is a small lesson in humility served straight up. We reasoned carefully. We reasoned honestly. We were partly wrong, and being partly wrong out loud, with all the data spread on the table for anyone in the world to check for themselves, is exactly how this whole thing is supposed to work. The youngest galaxies grew up faster than we said they could, and the universe, once again, turned out to be stranger and richer and more surprising than the neat story we brought along to explain it. Now let us come all the way home, right into our own solar system, our own back garden, because the very same lesson is quietly playing out on our doorstep, and honestly, it is the most delicious version of all. Every now and then, something from another star system drifts through ours, and how it moves tells us far more than what it looks like. Start with the ordinary case first, so the strange case lands properly. Most things you see in the sky belong to us, belong to the Sunday planets, comets, asteroids, all of them born right here in our own solar system, all bound to the sun, all looping around and around on paths set by one single thing. Gravity, give me the mass of the sun, and give me an object's position and its speed right now, and the mathematics will tell you exactly where that object will be next century and the century after that, and 1,000 years from now. That is orbital mechanics, and it is astonishingly, almost eerily precise. Clockwork you could set your calendar and your watch by. This is not a boast. We fling spacecraft across billions of miles of empty space, and they arrive at a moving target on schedule to the minute because the gravity math simply does not miss. It is the most reliable prediction machine humans have ever built. There is a threshold hidden inside that clockwork, and it matters enormously here, so let us name it. Escape velocity. Move slowly, and the sun's gravity keeps you looping around forever, tracing the same closed loop again and again for as long as the sun shines. Move fast enough past that one critical speed, and you break free entirely, flung out into the dark between the stars, never to return. Never. It is a clean line. Below it, prisoner. Above it, free. And here is the key. Anything that was born in our solar system is, by its very nature, moving slowly enough to stay. It formed here, out of the same swirling disk as everything else. It settled into its loop long ago, and it never had the speed to escape, because nothing ever came along to give it that enormous extra push. So every single native object traces a closed path around the Sunday. That is the tell. That is the fingerprint of belonging here, stamped on every rock and comet that is truly ours. So imagine our collective surprise when something came screaming in from the outside, moving far too fast to belong to the Sunday, on a path that was not a closed loop at all, but a hard open curve, the kind of trajectory that comes in from the deep dark, whips once around the sun, and leaves again forever, never to loop back. Its speed was above escape velocity from the very start, from before it ever got close, faster than the sun could ever possibly have accelerated it on its own. That is the dead giveaway, written in the geometry of its path. It was never ours. It came from another star entirely, drifting across the unimaginable emptiness between the stars for who knows how many millions of years before it happened, by pure chance, to thread its way through our little neighborhood and let us catch a glimpse, an interstellar object, a visitor from another sun. The first one we clearly caught was small, oddly elongated, tumbling end over end, and gone again almost before we fully understood what we were even looking at. Then came another, and another after that, with the clear marks of a comet on it, a fuzzy tail and all. Now, we had reason for a very long time that such visitors simply must exist. Must. Every young solar system flings out debris as it forms, cast off into the dark, so the space between the stars should be quietly littered with these wanderers, drifting in unimaginable numbers, but reasoning that they must exist somewhere out there, and actually catching one crossing your own patch of sky where you can watch it are two enormously different feelings. One is arithmetic on paper. The other is a knock at your own front door in the middle of the night. Here is where it gets truly interesting. And here is the turn we have been building toward. When these visitors pass close to the sun, we track them night after night, plotting exactly where they are against the background stars, drawing out their path with great care. And mostly they move precisely as gravity dictates, right along the predicted line, obedient to the clockwork. But sometimes there is a tiny discrepancy, a small extra nudge. The object speeds up or shifts its position by just a hair more than gravity alone can possibly account for. We have a name for this, and it is an honest name, honest almost to a fault: non-gravitational acceleration. Notice what that name does and does not claim. It does not claim to know the cause. It does not say what pushed the thing. It simply and precisely states that the object moved a little bit more than gravity accounts for, and that we therefore owe the universe an explanation for the extra bit. The name is a placeholder for an open question. It is a marker saying, work needed here. Now, what could cause a small extra push on a chunk of rock and ice as it swings near the sun? Reason it out with me. No expertise required. Just ordinary thinking. The sun's heat warms the object up as it approaches more and more, the way anything warms as you bring it near a fire. And if that object holds frozen gases inside it, ices that turn straight from solid to vapor without ever pausing to become a liquid, then those gases jet off the warmed, sunlit side in plumes, escaping into space. And a jet of gas streaming off one side is, quite simply, a tiny rocket. A tiny rocket gives a tiny push in the opposite direction. This is exactly precisely in every detail how comets behave. It is the most ordinary thing in the sky. We watch it happen every year. Occam's razor, that old and reliable principle that says, prefer the simplest explanation that fits all the facts you have, points a steady finger straight at venting ice. Nothing exotic is required, no new physics, no mystery, just a dirty snowball sweating in the heat and shoving itself gently off course with its own breath. And for the overwhelming majority of these objects, that is almost certainly the entire story, a dirty snowball from around some other star, warming up in our sunlight after an eternity in the cold, nudged this way and that by its own escaping vapor as it streams away into the dark. But here is the part I genuinely love. When one particular visitor showed a clear extra push, and yet we could not clearly find the jets of gas, the visible tail, that should have accompanied it, the honest scientific reaction was not to slam the case shut in either direction. It was not to declare it definitely ordinary, and it was not to declare it definitely extraordinary. It was to sit in the discomfort of not knowing, which is one of the hardest things a curious mind can be asked to do. Maybe the venting was simply too faint to see against the glare of the Sunday. Maybe the object was made of some unusual ice that leaves no visible trail our particular instruments were tuned to catch. Maybe our measurements had error bars, honest ranges of uncertainty, wide enough to quietly swallow the whole discrepancy without any mystery being needed at all. And a few people ask the question you are not really supposed to ask in polite scientific company. What would have to be true for this to be something built, something made? Not because the evidence pointed there. The evidence pointed calmly and steadily at ordinary ice, but because a truly careful thinker keeps even the wildly improbable options on the table until they are actually properly ruled out, while stating plainly and loudly which option they personally think is likeliest and exactly why they think so. Asking the question is not the same as believing the answer. Those two things get confused constantly, and confusing them is how good thinking goes bad in both directions. Here is the discipline that separates real thinking from wishful thinking, and it is worth carrying into every corner of your life, not just the sky. You do not get to pick the exciting answer simply because it is exciting. You do not get to reach for the thrilling story because it thrills you. You reason from the simplest explanation upward, patiently, and you demand real evidence at every single step of the climb. The venting ice explanation requires nothing new about the universe, just ice and sunlight, both of which we know for certain are there. The built object explanation requires an entire civilization and a launch and a journey across light years lasting far longer than our species has existed, and a purpose behind it, and a builder to have the purpose. That is an extraordinary claim stacked high with assumptions, and an extraordinary claim demands extraordinary evidence, none of which is anywhere in sight. So it waits patiently at the back of the queue, not thrown out, not banished, but certainly not let to the front on the strength of a hair's worth of extra motion. So the responsible answer, the one I would put real money on tonight, is that these are natural objects nudged by natural forces we simply have not managed to measure quite perfectly from so far away and so briefly, and yet the willingness to even frame the other question cleanly, honestly, in a form that could in principle be tested and killed by evidence without any embarrassment and without any breathless excitement is itself the entire point. That is the muscle. That is what it looks like in action. Because notice the shape yet again, an observation, a small anomaly, a single hair out of place, careful reasoning about everything under the sun that could possibly produce it, and a firm, disciplined refusal to leap to the thrilling conclusion. This is the very same move as the wall of old light, the very same move as the young galaxies. Reality does something slightly off script, something that does not match the page we brought. And instead of panicking or fantasizing, we calmly lay out every explanation side by side on the table and rank them honestly by how much brand new physics each one demands of us. The one demanding the very least, while still fitting all the facts, goes to the front of the line every time. A visitor from another star, moving just a hair faster than it should. Almost certainly nothing more than ice and sunlight and honest measurement error. And a perfect little lesson delivered right to our doorstep in how to think clearly when the universe surprises you close to home. So let us pull these three threads together now, because I promise you they point at the same place. And they truly do. Every honest answer about the cosmos turns out to be a boundary, not a wall. And the boundary is always drawn by what we can measure, never by what actually exists out there. Look carefully at what we just did together. Three journeys, wildly far apart, the furthest thing there is, the oldest light in the cosmic microwave background, glowing faintly from the moment the fog cleared. The youngest galaxies at the very edge of the observable universe, growing up far too fast for the tidy story we brought them, and a cold little visitor from another star, nudged by an unexplained push near the Sunday, three completely different scales of the universe. 46 billion light years out to the edge of sight, and a few tens of millions of miles across our own backyard. And every one of them told the exact same story with three different voices. In every single case, we found an edge, and in every single case, the edge turned out to be a fact about us, about our position and our instruments and our reach, not a fact about the universe itself. The observable edge is simply where light has had time to arrive. The wall of oldest light is simply where the fog stops us from seeing any further back. The surprise of the early galaxies is simply the edge of what our models managed to predict. The mystery of the visitor's tiny push is simply the edge of what our brief measurements could pin down. Every edge, every single one, is the boundary of our knowing, sitting quietly inside a universe that plainly, obviously continues right on past it in every direction we could ever point. This is the one thing I most want you to carry away from all of this. There is a difference between the edge of the map and the edge of the world, and it is the whole ball game. Every edge we have ever found out there is an edge of the map. The world keeps right on going past it. The old map makers, centuries ago, used to draw a border at the limit of the explored coast and write, beyond here, unknown. Sometimes they drew sea monsters in the blank space, but they never meant that the world itself ended there, that you would sail off a cliff. They meant only that their knowing ended there. Their charts ran out. That is exactly what every cosmic edge is. A note scribbled in the margin of the map that says, our knowing stops here for now, and here be the things we have not reached. And here is precisely why that should thrill you rather than frustrate you. It means the truly honest phrase in this entire field is not "we know," said with a puffed chest, and it is not "we have no idea," said with a helpless shrug. It is something far more precise and honestly far more beautiful than either. It is this: we do not know yet. And here is exactly how far the boundary sits, and here is the specific observation that would move it. That is not a shrug at all. That is a set of directions, a map to the frontier with an X on it and a road leading there. Think about how the Drake equation actually works. That famous way of estimating how many talkative civilizations might share our galaxy with us. It is not a fact, and it was never once meant to be mistaken for one. It is a row of things we do not yet know, honestly written out and multiplied together. How many stars have planets around them? How many of those planets are exoplanets sitting in the Goldilocks zone, that just right band around a star where it is neither too hot nor too cold, where liquid water could pool on a surface without boiling away or freezing solid? How many of those worlds actually grow life? How many of those grow life that eventually learns to talk across the stars? And how long such a talkative phase tends to last before it falls silent? It is a machine for organizing our ignorance into named separate pieces so that we can march out and measure them one at a time and watch the whole answer slowly sharpen into focus as each blank gets filled. And the Fermi paradox is that very same honest spirit turned into a single sharp question that stops you in your tracks. If the galaxy is old and vast and utterly ordinary, and we ourselves are nothing special by the Copernican principle, then others really ought to be out there, and some of them ought to have spread across the stars by now. So where is everybody? That is not despair dressed up as a question. That is a boundary drawn with a hard, clean edge, daring us to go and find out what sits on the other side of it. Maybe life is rare, far rarer than our hope. Maybe it is common but quiet, listening rather than shouting into the dark. Maybe it is common and loud, and we have simply not yet looked in the right place at the right wavelength for long enough with the right instrument. Each one of those is testable, at least in principle. Each one moves the boundary when we finally go and check it. So we now hunt for biosignatures, the chemical fingerprints of life in the light from a distant world, gases in a planet's atmosphere that living things would produce and keep constantly replenishing, gases that should not linger there on their own without something alive, making them so their steady presence would be a quiet shout of life. We listen for technosignatures, the marks of technology rather than raw biology, a deliberate radio signal with a pattern nature would not make, a spill of waste heat where there should be none, a something that should simply not be there. We use gravitational lensing, where a massive object sitting between us and something further away bends the light of the distant thing around itself, forming a natural cosmic magnifying glass, letting us peer further and fainter than our own telescopes could ever manage alone. And still, threaded quietly through every bit of it, is dark matter, the unseen mass whose gravity we can weigh with real precision by watching how galaxies spin and how light bends, but whose actual nature we cannot yet name at all. Another boundary, another named piece of honest ignorance, sitting patiently in the ledger, waiting for someone to fill it in. Every single one of these is the same posture, repeated at every scale from the atom to the horizon. Draw the boundary precisely with numbers where you can say clearly what is on this side. The known, the measured, the checked, admit plainly and without shame what is on the far side, the unknown, the unmeasured, the waiting. Then build the instrument or build the argument that moves the line outward by an inch. And then, having moved it, do the whole thing over again from the new frontier. That is the convergence I promised you. 3 edges, wildly different, one single truth underneath them all. The cosmos is knowable, but it is not yet known. And the gap between those two things, between knowable and known, is not a wall to bang your head bloody against in frustration. It is the whole adventure. It is the entire reason there is anything left to do at all. Fill the gap completely, and you would be left holding a finished universe with nothing whatsoever left to wonder about. And honestly, what a quiet and disappointing thing that would be. The gap is not the problem. The gap is the gift. So let us bring it home. We started with an impossible question. Where does the universe end? A wall seemed impossible, and forever seemed impossible. And you were caught helplessly between 2 ideas your mind simply could not hold, flinching back and forth between them like a bird trapped in a room. And here is where we have actually arrived together, step by checkable step. We did find an edge. It is measured, it is real, and it sits about 46 billion light years away in every direction you could point, but it is the edge of the observable universe. The edge of what light has had time to bring us in the roughly 13.8 billion years the universe has existed, stretched out to that larger distance by the patient expansion of space beneath the traveling light. It is not the edge of everything. It is only the reach of the messenger. And nothing more than that. We found the oldest thing there is, the cosmic microwave background, the free light from the exact moment the early hot fog finally cleared, 380,000 years into the story. A wall of light you cannot ever see past, not because your telescope is too weak, but because there's no older light anywhere to catch, because before that moment, no light could travel free in a straight line. And behind that wall, in space, is more universe grown up now into galaxies we will simply never witness in their present form, because we are stuck forever seeing only the postcard they mailed us when they were newborn. We went right up to that edge and found galaxies too big and too bright and too soon, calmly breaking the tidy story of slow assembly, that we had reasoned out so carefully and so confidently. And instead of hiding the mismatch or quietly pretending it never happened, the right and honest response was to celebrate it, because a prediction that can be proven wrong and then gets proven wrong is worth infinitely more than a comfortable story that risks nothing and therefore teaches nothing. Falsifiable, that is the word. That is the whole game, top to bottom, edge to edge. And we came all the way home to a cold little visitor from another star, an interstellar object moving a hair faster than gravity alone allows, showing a non-gravitational acceleration that most likely comes from perfectly ordinary ice venting away in the sunlight, plain as any comet we have ever watched. And there we practice the hard discipline of preferring the simplest explanation that fits, while keeping the wild one on the table, unrewarded but not banished, until it is properly ruled out by evidence and not by mood. And all three, across the very widest and the very smallest scales you can possibly imagine, said the exact same thing in the exact same steady voice. Every edge we find is an edge of our knowing. The universe itself keeps right on going, calm and indifferent, past every last one of them. The map has borders, the world does not. That is the cosmic perspective I most wanted to hand you tonight. And notice that it is a way of standing rather than a list of facts to memorize, not a set of final answers to be filed away. A way of standing in front of the unknown that is precise about exactly how much is unknown and delighted by that gap rather than defeated by it. Distance and time turned out to be the very same currency, both of them spent by the same traveling light. And at every single step along the way, you could check the reasoning from your own chair, with nothing more than the speed of light, the age of the cosmos, and a bit of honest arithmetic you did yourself. Nowhere did you have to take anyone's word for it. Mine least of all. You reasoned your own way to the edge of the visible universe, using only tools you already trusted before you sat down. That is yours now. Nobody can ever take it back, and no better telescope built by anyone can ever embarrass it, because it was never about the telescope in the first place. So let me be honest with you now about what is still genuinely wide open unknown, because that honesty is the whole point of everything we just did together. We do not know whether the universe is finite or infinite. We know it is far bigger than what we can see, vastly bigger. But whether it wraps around gently on itself, like the surface of that balloon, or ends somewhere forever unreachable, or truly goes on and on without any end at all, we cannot say, because the observable edge blocks the view completely, and it always will, for everyone. We do not know what dark matter actually is, even though we can weigh it precisely by its gravity and watch its effect on how entire galaxies spin. We can feel it. We cannot name it. We do not know in any confident way whether the surprising early galaxies mean our models need only a small, gentle repair or a large and painful one. And good, honest people are disagreeing about it in good faith at this very moment. We do not know if we are alone in all of this. The Drake equation still has terms in it that are pure and honest guesswork blanks waiting to be filled. And the Fermi paradox still stares silently back at us without any settled answer. And we do not know for certain if any interstellar visitor has ever been anything but rock and ice, though the honest bet, the one I hold with both hands, is that every last one of them has been exactly that, and I would tell you the very moment it changed. Here is the part that I find almost unbearably good, almost too good. Every single one of those open questions has a boundary you can actually point to and a specific observation that would move it. Not one of them is a mystery in the hopeless, locked away, forbidden sense. They are frontiers. They have coordinates. They have edges you could walk right up to and lay your hand on. And someone alive on this earth right now may well be the one to push one of those lines outward. It might even be a child who has not yet looked up at a dark sky for the very first time, who will one day grow up and build one of tonight's answers into a far better and deeper question than any we can ask right now. You came here for the edge of the universe, and I truly hope you are leaving with something a good deal better than an edge. I hope you are leaving with the settled feeling right in your chest that the not knowing is not a locked door at all, and never was. It is an open field, mapped carefully right up to the tree line, well lit and well measured, with the far side still dark and still waiting, and a clear, inviting path leading straight into it. Thank you, genuinely and without any flourish, for giving me this stretch of your time. It is a real gift, and I do not take it lightly, that you would spend the better part of an hour thinking about the shape of everything with me, checking each step, refusing to be rushed through any of it. If it left you even a little more curious than you were when you first sat down, then it did its job and then some. If you would like to keep wandering out to these boundaries together, night after night, then subscribing is simply the easiest way to make sure the next one finds its way quietly to you. No rush, no pressure, nothing at all to buy. Just an open, standing invitation to keep looking up and to keep asking the questions that do not yet have their answers. There are so very many of them left, and that, when you really think about it, is the best news there is. Thank you for being here.